Alright, Chapter 15, Track Junctions and Simple Track Layout. The track junctions are formally the combination point for the crossing, main object for the transfer rail vehicles from one track from another, enable them to cross from the track one track to another, depending on the requirements of the traffic that can be surveyed to a simple type of the track junction, simple track layouts. The most commonly used layouts are discussed in the following sections. Turnout simpler flexure. The turnout simpler flexure is one that continues with run over the same direction mainline curve the after the branching off the degree of the turnout curve the higher the mainline curve the degree of the radius of the turnout curve is given formula. Main line turnout. The turnout is similar flexure where ds is the degree of the outer rail of the turnout curve of the straight track of the dm, the degree of the rail of the main track of the crossing lines, and e of the inner rail of the degree of the rail of the turnout curve of the width of the crossing lines, and the outer rail rs of the radius of the outer rail of the turnout curve of the straight track of the rail rt with the radius of the rail turnout curve on which the crossing lines outer rail. Alright, your turnout contrary flex. The turnout contrary flex is one that takes off towards the direction of the opposite of the mainline curve. Then case the degree of the radius of the turnout curves are given in the formula. Turnout D2 and mainline DM. The turnout with the contrary flexure. Here DM the degree of the rail. The main track of the well. The crossing lines of the outer rail 15-2. Or a symmetrical split. The straight track is split with the two different directions from the equal radii of the layout with known as the elliptical split. In other words, symmetrically split with the contrary with the flex of the radii. Two curves are the same. The salient features of the symmetrical split are found in the layout that consists of the pair of the parts of one actual acute crossing the four curved lead rails and two check rails. The layout of the symmetrical is about with the center line with the means of the radii mean the main track as well as the branching track of the equal layout provide the facility diverging vehicles both towards and left and is suitable. The suitable location space constraints of the occupied with a comparative bunch less than the turnout of the traffic. Figure 15-3 shows the symmetrical split facing direction A2 and A2, the 3-4, the three-throw switch. The three-throw arrangement of two turnout take it of the same point with the main line track of the three-throw switch contrary to the flexure of the similar fixture shown in three-flow switches used in the congested good yards entry with the point with the locomotive over where the great limitation of the space. This shows a three-throw switch contrary flex. The three-throw switch has two switches, each with the switches and two tongues, the rails, and side by side with the combined heel with the block both of the tongue rails and the switch that can be operated with such a way that movement is possible either direction of straight with the right with the left. The three-throw switch is obsolete in order that they may improve the harder hazards, particularly when higher speeds because the double switch may lead to derailments. Figure 15-5 shows the three-switch similar flexure. Double turnout is the improvement of three-throw switch, and the double turnouts are staggered and take off of the main line in two different places. Eliminates the effect of the three-throw switch and the heel of the two switches is kept in a certain distance to each other. The distance between the two sets of switches should adequately to allow the room usually throw over the point. Main line, branch 1, branch line 2. Double turnouts can be similar flexure with the two turnouts take off at the same side track, than the contrary with the two turnout point take off at the two different directions. Double turnouts are mostly used in congested areas, and particularly where the traffic heavily is economy of space. 15-7, the double turnout with the contrary flex. Crossover between two parallel tracks with an intermediate straight length. With the crossover between two parallel tracks with an intermediate straight length can be designed with applying two methods. The Coldine simple line within case of two parallel distance d with either connected with the crossing over the small length with the strength of the portion track line between the two theoretical nodes of the crossings, straight position of the track and straight portion of the track. ST can be calculated with the using the following: the straight track equal to the distance from distance minus the gauge to n number minus the gauge of the square root of 1 plus the number 2 squared. When the gauge of the track at the end of the number of the crossing overall of the length of the OL, the crossing of the tangent point of the track of the tangent or other track, the pounding of the adding length of the curve leads to the two turnouts along the straight position between the theoretical nose closure over the length of the equal to OL on one turnout at plus ST on the straight track of the OL overall length of the turnout. Since the value n2, the n is number of crossings squared is variable compared to the m1 to the value of the square root of 1 plus the n number of crossings squared can be taken approximately. N is simplifying total length of TL is equal to d plus 2g times n, 2g n minus plus st plus 2gn, or 4gn plus st. 15-8, you shows the crossover between two parallel tracks. 1.85 crossover exists for the BAG parallel track for the center 5 meters apart. Finding the length of the straight track overall length with the crossover, the use of the Cole method given the D is equal to 5 millimeters. Number of tracks is 8. Number of crossings. Number of crossings, alright, straight track month, Alright, your IRS design. The distance of the theoretical nose measured along with the straight track with the given the formula as straight track is equal to D minus G with a gauge minus gauge of the section secant A and this cotangent A with the simplification as standard track is equal to D cotangent A minus G cotangent A divided by 2. The straight distance between the theoretical nose and the theoretical nose along the track of the string track of D is the distance of the center of the two tracks, the gauge, and A at the angle of the crossing. Similar with the distance of the theoretical nose and the theoretical nose to all the crossing given the formula. CF is equal to D minus G with the sequent A times cosangent A plus G cotangent A. The CF distance of the TNC also along the crossover the distance of the center track. The G of the gauge and A is the angle of the crossing. 1 in 12 crossover IRS type of the lathe with the broad gauge parallel of the track with the centers of 5 meters apart. The straight calculated straight track distance of the theoretical nose of the crossover. Alright, diamond crossing is provided with the two tracks either of the same gauge with a different gauge each of the distance of the two acute crossings A and C with the two of the crossings B and D with the typical diamond cross with the tracks with the same gauge each other than shown in figure 15.9 with the layout of the A, B, C, D and rhombus of the four equal size length of the various constitute the base may be calculated as follows. EB equals DF and A equals AF cotangent A equals GN A B equals BC equals G cosine tangent A. Diagonal AC equals G cosecant A divided by 2, A and diagonal BD is equal to G gauge cosecant A minus 2. Alright, your diamond crossing, okay? It can be seen that, from the layout of the length of the gap of the point B and D and the creep of the angle of the crossing, the creep of the longer creep, grabs gaps and creep of the change of the wheels, particularly with the small diameter, deflected with the wrong side of the nose. On the Indian Railroad, the flattest diamond crossing permitted with the broad gauge and meter gauge is routes of 1 and 8.5. All the diamond crossing single and double slips may also be provided with allow the vehicles to pass over the track one of another. Single slip and double slip. The diamond cross track of each of their both the trains if they either cannot change the track of the slip, they're provided with allow the vehicle to change the track. Slip of the arrangements can be eitherly slip. Single slip with the double slip, single slip with the two sleds with the joints vertically. Vehicle of the one direction can change the tracks, and single slip is shown figure 1510. With one of the train tracks can change the track D, whereas the train on the track C remains on the same track that's continue on to the track D. A is to B, and A goes to B, and B and diamond crossing C to D, and C back D to C, A to D, and D to A. In case of double slip, the foresight of the point of trains after the both direction change track with the double slip shown in figure 1511. The trains if the both track A and C can move in either B or C to D. 15L, the double slip. The A can go to B, B to go to A, C to go to D, and D to go to C, and double slip. The A goes to D, and B goes to C, and C goes to B. Alright, 1572. The improvement of the design of the diamond crossing order to smooth the ride of the diamond crossing following the improvement generally made with the provision of 25mm high check rail, the reduction of check rail, the clearance of 3mm in K for the other two's crossing. Two broad gauge tracking crosses each other with the angle of 1 and 10, calculated the important dimension of the diamond crossing. The data given in the file with the number of the crossings is 10. The gauge is 1.7 meter and 1.67 meters, 76 meters. The number of the crossings equals the cotangent A, or 10 equals the cotangent A. Therefore, area is equal to 5 degrees 42 and 32/8 of an inch. EB is equal to DF, and AE cotangent A is equal to GN. 1.676 times 10 is 16.76 meters. A equals to BC is equal to G of the cosine A is 1.676 times 10.05 is 16.85 meters. AC is equal to G gauge cosangent A cosecant A equal divided by 2. 1.6 cosecant A 5 degrees 42 feet and 38 of an inch and a half. 1.676 20.10 33.70 meters. Alright, BD is equal to gauge sequent A 2, 1.672 sequent 5 degrees 42 feet 3/8 of an inch and 2 divided by 2, 1.676 1.014 1.7 meters. Or your scissor crossover. Scissor crossover to mate with the transferring of the vehicle from one track to another, vice versa, provided the lack of the shape that does not permit the provision. Two separated crossover the system of 4 pairs of switches and 6 actuating crossing, 2 obtuse angle the checks, etc. 15 to 12 shows the spring crossovers, scissor crossovers. For scissors cross over the continuum, commonly used the three types depending on the distance between the two parallel tracks joined with a brief distance script in the country and cross over the file. The first type of the actual crossing the diamond fall with the lead of the mainline track and turnout. With this case, the lead of the mainline turnout is considerably reduced, hence is not satisfactory. Remember, the second type of the actual crossing diamond falls opposite with the crossing of the mainline turnout. Here, both the crossing lines opposite with each other, with the resulting simultaneous drop of the wheel resulting in jolting. There is no desirable type of layout. Third type of the crossing over the acute falling. Crossing falls out with the lead of the main crossing actuating crossing the diamond as far as away from the crossing mainline track. This is the most satisfactory arrangement of the three layouts. Okay, gauntleted track. The temporary division is provided with a double line track which allow the track shift of the path through the other track of the path of the tracks run together with the same sleeper to provide a useful connection with one side of the bridge over the double line section required with the block of the other major repair of the building. Special layout of the two crossings at the end of the no switches. Alright, this shows your gauntleted layouts. A track under repair parallel line, theoretical nodes A, C, and AD. Gauntleted tracks are also in sections where there has been operated with the mixed gauge with the both broad gauge, meter gauge for the strong short stretch, and in such cases both the tracks are lead on the same set wooden sleepers. Alright, this shows the meter gauge and the broad gauge, and the broad gauge. The singular feature of the gauntleted tracks are followed with the two tracks laid out with the same sleep with the two sets of the crossing without any switches. The gauntleted tracks are economically use the mixed gauge and save for the tracks the broad gauge, meter gauge. The layout when you use the double line bridge that is under the repair. You also use the X now economize the cost of the double line bridge. 510 gathering line, also called the ladder track. The track where the number of the parallel tracks together and merge. Alternatively, the number of the parallel tracks are branched off of the gathering line. The gathering line is defined with the turnout angle of the angle of inclination, the angle of the ladder track of the parallel tracks. Gathering line and crossing angle. The angle of the inclination gathering line are the same as those turnouts as is said to be angle. The crossing situation there might be some back with the crossing of the turnout stock joined to the next of the turnout closure rail to be used. The angle of the later track may be equal to the angle of the crossing. Two tracks intersecting the three-door node of the crossing. No curve that introduce the turnout across the connecting the parallel tracks. Gathering line limiting angle at the limiting angle. In this case, the angle of the gathering line is greater than the cross angle of the curve of the plow of the back leg of the crossing. The back leg of the crossing is followed with the stack joint with the next turnout with no space. The waist limiting angle of the gathering line is given with the following formula. Since the sin of the limiting angle of the space between the two adjacent parallels over the length of the turnout, or D equals X over D over X gathers, it can also be laid at 2A, 3A, and twice the 3 of the crossing. Such gathering lines are generally found with the marshalling yard that is known by the balloon layouts. So the layout with the marshalling yards, however, the herringbone grid, the various sidings of the marshalling yards are also most equal in length. There is no particular design. This shows the mainline gathering line A, B, and D, loop 1, main line, loop 1, loop 2, and loop 3 distance of the D. C and D also is your angle A, and it is the same for the gathering line herringbone. A, E, B, A, D, B, C, E, D, C, B, triangle. Okay, a triangle is most provided with a terminal yard charging of the direction of each of the engine. Turnabouts are usually for the purpose of the most costly, cumbersome, that present a lot of problems in the maintenance. Normally, the triangle is preferred enough to avoid the triangle considered symmetrically split with the R turnout, the P and Q, along with the lead rails, the check rails, etc. Change the direction engine standing P, the first angle, then R, then the Q, then back to the P, and then following these movements, the direction of the engine gets changed. The concept of change the direction was more relevant. In this case, the steam locomotive is not applicable to the electrical and diesel locomotives, which operate conveniently on both sides while phasing. Steam locomotives, Indian rail of the train triangle, the most redundantly. This shows the triangle. 1516 shows the triangle. Double junction. The double junction is required for the two more mainline tracks running on other tracks branching off the these mainline tracks is the same. Or a double junction shows the two main lines, a diamond and branch line, branch to direction layout of the double junction consists of the ordinary terminals with one or more diamond across, depending on the number of the parallel trains. The double junction may occur with the straight and curved main lines, and the branch lines also be the single. The double line type of the junction is quite common with the congestion area. Congested yards. Traction junctions are required for the transfer railway vehicles one track to another, and enable the train with the cross. And several types of the junctions can be laid by using a different combination point of the crossing. Commonly used the layouts having the discussed in chapter help us sketch and solve examples. Chapter 16: Rail joints and welding rails.